Dear students, after completing Faraday's first law and second law, today we have to discuss about the applications of Faraday's two laws and some problems related to it. These applications listed here are 4 in number, and all of them we have studied in previous classes. First one, calculation of Z. What is Z? Z is the electrochemical equivalent. Electrochemical equivalent can be calculated by dividing equivalent weight with 96500 coulomb. This is the electrochemical equivalent calculation from Faraday's first law. Second one, bring the relation between 1 mole electron and the charge carried by them. Using this electron charge and the relation, we have stated that 1 mole electron always carry total charge of 96500 coulomb, and also when this much of electricity is passed through an electrolyte, 1 gram equivalent of the substance is deposited at the respective electrodes. This is the second application that also we have discussed. Then third one, calculating the electronic charge. Total charge of 1 mole electron is 96500 divided by 1 mole means 6.022 into 10 raised to 23. Then we will get 1.602 into 10 raised to minus 19 coulomb. This is the charge of 1 electron. Total charge of 1 mole electron is 96500, that has been divided by 1 mole or Avogadro number to get the charge of 1 single electron. Fourth one, from the deposited mass, the amount of electricity can be calculated. This is very simple. If someone is saying you that during the process of electrolysis of magnesium chloride, at cathode they got 2.4 gram magnesium. So you can simply say that they have used this much of this quantity of electricity. How? As far as concerned with magnesium, equation is Mg2 plus 2 electron gives Mg. What this 2 electron indicate? This 2 electron says that 2 Faraday of electricity can deposit 1 gram atom of magnesium, that means 24 gram. 2 Faraday. Here they have told you that they have got 2.4 gram. So they have passed 0.2 Faraday. Then you will get the amount of electricity used for this purpose. This kind of calculation is also possible by using Faraday's law. Now we have to come to the problems. First problem, how many grams of chlorine can be produced by the electrolysis of molten sodium chloride with a current of 1 ampere for 30 minutes. Here current I is given, time t is given, but it is in minute, but we need it in second, and question is how many grams. So from the previous discussion you can clearly say that we have to calculate W, and they have given I T. The real equation is W equal to ZIT. Z means electrochemical equivalent. What is Z? Z equal to E by 96500. E means equivalent weight of chlorine, that is 35.5, not 36, 35.5 divided by 96500, that is Z. I they have given as 1 ampere into 30 minutes, so we have to convert it into second by multiplying with 60. On solving, you will get the answer 0.66218 gram of chlorine is liberated. Here question was the amount of, or how many grams, that was the weight of the chlorine. But if you have been asked to calculate the volume of chlorine, then how it can be done? We know that 71 gram of chlorine, that means 1 mole chlorine, Cl2, not Cl, Cl2 occupies a volume of 22.4 liter. But here actually we have 0.66 gram, so its volume is 22.4 divided by 71 into 0.66218, then you will get 0.208 liter is the volume. But in question they have not asked you to find the volume, but for an example I have explained it. The same problem you can do in another way. Here question is about chlorine. So equation for chlorine is 2Cl minus gives Cl2 plus 2 electron. From this 2 electron we have the answer. This 2 electron indicate that 2 Faraday of electricity can deposit 71 gram, that is its molecular mass. 2 into 96500 coulomb can deposit 71 gram. But here Q equal to IT. I means 1 into T means 30 into 60, 1800 seconds, that means 1800. So this much of 1800 coulomb, this much of electricity can deposit 71 divided by this quantity come here, 2 into 96500 into this is the amount of substance deposited by passing 1 coulomb. But here we have this much of coulomb, so we have to multiply with that number 1800, then you will get 0.66218. Here also answer is same, but we have used two approaches. Here first you have to think about the equation through which we can approach the answer. Here you are thinking about the concept. Here even if you don't know the concept, you can do it by knowing the equation, but here you have to think about the concept. 2 electron, that means 2 Faraday can deposit 1 mole, that is 71 gram, then it is converted to the corresponding value for 1800 coulomb. This 71 and 2 cancel, 35.5, then it will be same as it. So any approach you can use to find your answer. Next question. Calculate the quantity of electricity required to deposit 10.8 gram silver through the electrolysis of silver nitrate solution. You have been provided with a silver nitrate solution. On electrolysis, definitely you will get silver at the cathode. And during that process, you have got 10.8 gram of silver. Then, how much of electricity used? Again, we have W is equal to ZQ. They have asked to find out Q. Q means quantity of electricity. Then Q equal to W by Z. W is 10.8 divided by Z. What is Z? E by 96500. Then E. As far as concerned with silver, atomic mass and equivalent weight are equal since its valence is 1, that is 108, divided by 9650, then this number will come to the numerator. On solving it, it will become 10 here, 10 and this 0 cancel, and 9650 coulomb is the answer. 9650 coulomb is required to deposit 10.8 gram of silver. But at the same time, conceptually we can say that equation for silver is Ag plus plus 1 electron gives Ag. This one means 1 Faraday of electricity deposit 108 gram silver. That means 96500 coulomb can deposit 108 gram. Question is 10.8 gram. 1 by 10th of this quantity have been asked in the question. Then 1 by 10 quantity of electricity is needed. 9650 coulomb is required. Again the same answer. Next one. How long a current of 2 ampere need to be passed through copper sulfate solution to deposit 3.17 gram copper. 3.17 gram copper. How long? Which parameter we need to calculate? That is time. Current I 2 ampere is given. Weight or mass, that is also given. So we have W equal to M equal to Z into I into T. M is 3.17 gram. Z is 31.17, that is the equivalent weight of copper, divided by 96500. Z is E by 96500 into I 2 ampere into T. You can solve it to get the T. On solving it, you will get the answer 4814 second is required to deposit this much of copper at the cathode. Conceptually you can think to get the same answer, you can try it. Fourth problem, you have to read it. During the electrolysis of salt of an S block element Z 2.3834 give 2.3 gram of the element is deposited at cathode. Calculate the quantity of electricity used in this process. Again, W equal to ZQ. You have been asked to find out Q. Here Q equal to W by Z. What is here? Q equal to W by Z. What is W? This is W 2.3 divided by what is Z? 2.38 34 into 10 raised to minus 4. When it is calculated, you will get 9650 coulomb as the answer. So I think you now understand that element. Which is that element? 9650 coulomb can deposit 2.3 gram. So 9650 coulomb can deposit 2.3 gram. That is 1 Faraday. 1 Faraday deposit 23. That means 23 is the equivalent mass of that element. That is sodium. Then we come to another problem. Same quantity of electricity passed through solutions of silver nitrate and nickel sulfate. Two solutions, silver nitrate and nickel sulfate, they are connected in series, and respective mass during electrolysis, silver deposit 4.316 gram, nickel deposit 2.348 gram. According to Faraday's second law, the masses deposited will be in the ratio of their equivalent mass. So you have to calculate equivalent mass of nickel. Silver is 108 gram. Mass of silver by mass of nickel equal to equivalent mass of silver by equivalent mass of nickel. Mass of silver is 4.316, mass of nickel is 2.34, equivalent weight of silver is 108, then equivalent weight of nickel is cross multiplying. You will get 108 into 2.348 divided by 4.316. You will get the answer 58.754 gram. This is the equivalent weight of nickel. This is the application of Faraday's second law.